Ah, the taste of Pepsi after a long day at school. How many of you guys went out and had that snack that we talked about in class today after your first day of school? I had to settle for the Pepsi instead of the popcorn, but overall I thought it was a fantastic day. All right, it's time for Skills Review Day 2, focusing on rational numbers. You might be thinking to yourself, what is a rational number? What's the difference between rational and irrational? I've heard these things before, but I've just forgotten over the summer. Just a reminder that irrational numbers are crazy numbers. So this could be things like pi, or the square root of 5, or maybe your math teacher. Rational numbers are not crazy, and they're not crazy because you can write them as a fraction. So in this section, we'll be working with rational numbers. That would include things like fractions, decimals, and integers. We will be adding, subtracting, multiplying, and dividing these rational numbers, as well as putting them in order from least to greatest. Let's kick it off with a little bit of vocabulary. If I'm looking at the important words to know in this section, probably most of them are already familiar to you. We can look at integers. Integers are the set of numbers. If you see I wrote ... -3, -2, -1, 0, 1, 2, 3, ... Those ... dots just mean that it goes on and on forever in both the negative and the positive direction. We could list those out for the rest of the night, but I think we'll stop there. Okay, the origin, your social studies teacher would want you to know that your origin is where you start. So if I'm thinking about a number line, the origin on the number line is going to be the point labeled 0. Opposites. Most people, if I said, hey, what's the opposite of 7? They would say -7. What's the opposite of -10? They would say 10. But the reason those are opposites, if I look at a definition, is because they're two numbers that are the same distance from the origin, but on opposite sides. Two numbers the same distance from the origin, but on opposite sides of the origin. And the last one is the absolute value. Absolute value is the distance from the origin. Oftentimes, my students will say, well, isn't that the thing that always turns it positive? It is, that's true, but the reason is because we're talking about a distance. Imagine I sent us all out to the track, and we're gonna go out and I said, hey, let's run 100 meters. Okay, that 100 meters would have to be positive. You might say, well, couldn't I run backwards? Sure, you could run backwards if you wanted to, but the distance would remain the same. You would have still run 100 meters, you would have just gone backwards. Okay, so same thing happens on a number line. I could go to the left of the number line, I could go to the right of the number line, but either way, I've gone a certain distance, and that distance either needs to be positive, or if I'm taking the absolute value of 0, it could also be 0. So it's either 0 or positive. Let's work through the three examples given. If I look at the first one, it's asking me to find the absolute value of -5.2 plus 3.9. If I take a look at the problem, it's important to remember that I need to perform the operation inside of the absolute value before taking the absolute value. So in this case, I need to do -5.2 plus 3.9 and then find the absolute value. So if I look here, I'm going to have to subtract. So if I take 5.2, I'm subtracting out 3.9, I get 1.3. Because the negative is bigger, that 1.3 is also going to be negative. Okay, so if I look at this right here, I get a -1.3. Now I can think about taking the absolute value of -1.3. So how far is -1.3 away from the origin? Well, the absolute value of -1.3 is 1.3. In example B, I have -3 smushed right up against to the absolute value of -9 plus 2. Okay? Because there's nothing in between the number and the absolute value, that means I'm going to multiply. Okay? So I can think about taking -3 times, okay, times the absolute value of -9 plus 2. Well, -9 plus 2 is -7. Okay? Now I'm ready to take the absolute value of -7. So I have -3 times 7. -3 times 7 is -21. In our final example, I have -10.3 minus the absolute value of -4.5. Well, the absolute value of negative 4.5 is 4.5. So in this case, I'm taking negative 10.3 minus 4.5. Because they're both negatives, they have the same sign, I'm going to add those two together. So when I add those two together, I will get negative 14.8. All right, the remainder of notes is filled with problems for you to complete for class tomorrow. If I look at the first couple of examples, it's having you put things in order from the least to the greatest. When you think about those, remember the least numbers will be the farthest left on the number line, and the greatest numbers will be to the farthest right on the number line. Okay, G through K have you perform some operations with rational numbers. Please remember a couple of things when working these problems. First of all, if I'm adding and subtracting fractions, I need to get a common denominator. Also remember to be really careful with the positive and negatives. We'll talk more about those in class tomorrow. Have you ever had a question you didn't know the answer to, and it just kept you up at night? You just couldn't stand it. So, here's my question that I've been on the search for an answer to. Why is 8 divided by 0 undefined? I went to try to get some help, and here's what the people said.
I don't know. Ask an algebra kid.
I don't know. Ask an algebra kid.
Maybe you can help me in class tomorrow.